Yes, in the last lecture, I have completed creating a model. So let me recall what I did it in the last class. So I completed grid system in ETABS. I completed this grid system in ETABS. Next, story data, define materials. We defined two types of material. One is M25 grade of concrete and Fe 500 steel. Next, defining sections. So we defined columns. So columns as 300 into 500 millimeter, and beams 200 by 500 millimeter, and we have two types, again beam size 200 by 600 mm, and we completed modeling of columns. We completed modeling of columns. Okay, so in today's class we will discuss how to model beams and slabs. So I will show you how to model beams and slabs. So this is the yesterday's model. So if you see here, so just I have completed the modeling of columns. So you can rotate this model by pressing shift key in keyboard and your mouse scroll button. So you can rotate like this. See here, I have modeled columns in all the floors. So next we will take up modeling of beams. See here, if you refer my architectural plan, so these horizontal beams are 200 by 500. Again these vertical beams are 200 by 600. Clear? So first I will model horizontal beams. Okay. So if you see the section properties, frame section, already I have the beam properties. One is beam 200 into 500 mm, beam 200 into 600 mm. Okay. To draw the beams, you go to this option, or in case of draw, you go to draw beam bar column bar brace object. So you select first one. So first I will model horizontal beams, that is, so property 200 by 500. Okay. So always model your horizontal beams from left to right. So you please remember these things. So while modeling your horizontal beams, you model it from left to right. So you remember this one, horizontal beams are modeled from left to right. Okay. So you select the property beam 200 into 500 mm. You just click on this grid intersection. So just I will zoom it. So you just zoom in. You just click on this grid intersection. So you model it from left to right. So first click, and this is your second click. So next click on this intersection. So if you cancel this option, on mouse you click right button. Okay, so you take this one. If these grid lines are disturbing, you can remove these grid lines. So go to view, set grid system visibility. You can remove these grid lines. Okay, or you can bring it back. So you just click on this. So here my story option is all stories. So whenever I draw anything it in ground floor, so it will be reflected or copied to all the remaining floors. If you see here, I will go to add new window. See here, all your horizontal beams are modeled in all floors. Why? Because my option was all stories. Okay, so next I will model vertical beams. So just I will model my vertical beams. So for vertical beams are modeled from bottom to top. So you remember, vertical beams are modeled from bottom to top. Okay, so you select the draw beam option. So my vertical beams are of size 200 by 600. 200 by 600. So vertical beams are modeled from bottom to top. So you just click on this grid intersection. Next. Okay. So if you see here, so my story option is all stories. If I draw anything in present ground story, it will be copied to all the stories. You observe this 3D view. See here. So you just click on this grid to grid this. Yes, see here. You just observe the 3D diagram. So you will get beams on all the floors. Okay, so this is modeling of beams. So next, my question is, this span is from C to D. I think span is 6 meter. So I need beam exactly at the center. I need a beam exactly at this center point. How to draw that? So for which, first you need to identify the midpoint of this beam, these two beams. To track the midpoint of these two beams, so you go to draw, snap options. So in snap options, ensure you should select line ends and midpoints. Apply. OK. So you just remove this. So now you go to draw beam. See here. Now you can easily track the midpoint of this beam or midpoint of this beam. How to add a beam? I need a vertical beam here. So please remember, vertical beams are modeled from bottom to top. So click on this joint. So track the midpoint on this beam. Okay. You just click it. See here. The new beam has come up. If you observe this 3D view, see here. So this is your new beam. So which is placed exactly at the center. Even you can measure the dimension, measure the distance also. So you go to draw dimension lines. Draw dimension lines. You click on this joint and this joint. See here, this distance is 3 meters. This distance is 3 meters. So how to remove these dimension lines? You first click on mouse right button. You just turn on this lock on screen grid system edit. You just click on this. Then you can select this dimension lines on keyboard plus press delete. Okay. So this is the beam which is created exactly at the center. Okay. So next is I need beam at this location. So which will be at a distance of 1.5 meter. I need a beam. So let it be beam 200 into 600. Beam 200 into 600 mm at a distance of 1.5 meter. See here, if you see your global axis, this will be your positive x and this will be your positive y. Okay. So you first select this beam. This is your reference. So go to edit. So there is an option called replicate. You go to replicate. So on linear. So this is your positive x. You need a beam along negative x. So on dx you put it negative sign. What is the distance? 1.5 meter. You just drag your mouse to apply. Don't click it. Just you drag here and observe the diagram. Your beam will be visible. So if you click OK, so this is your new beam. So this is your new beam created at a distance of 1.5 meter. So how to check? Go to draw, draw dimension lines, click on this joint and this column joint. See, this will be 1.5 meter. So this is your replicate option. So this is your replicate option. See, my story option was all stories. So these two beams are created on all the stories. If you just move up, see here, on the first floor also you have same beam at same location. On the second floor also same beam. Next on third floor and on the roof also. Why? Because my story option was all stories. Okay. So how to delete the beams? So you select this beam, ensure all stories, So this beam selected on all the stories. If you see the status bar, here it is showing 5 frames are selected. So your beam is selected at ground floor, first floor, second floor, third floor and roof. So 5 frames are selected. So once you select the beam, on keyboard you click delete. Similarly for this beam also, you select the beam, on keyboard you click the delete. This is how you can create the beam. Okay. I want to explain something. Okay. See here. Here you have one beam which is beam 200 into 500 mm. So how to divide this beam? Which means I need a separate beam, one single beam from here to here. Same B 200 into 500. From here to here I need a single beam, individual beam. So that is beam 200 into 500. Okay, for which you first you select this beam and you select this joint. Select the beam, select the joint, go to edit. So in edit menu, edit frames, you go to divide frames. So here there are three options. You select this second one, break at intersection with the selected frames and joints. So where there is a joint here, the beam will be divided at this location. So you click on apply. Okay, now see here. So this is a single beam from here to here, it is single beam. So beam 200 by 500. So from here to here again it is a single beam. So initially it was from this column to this column you had one beam. So now I divided into two beams. How to join these two beams? Again same simple procedure. You select these two beams, and you select this joint, go to edit frames, you click on join frames. See here, now it has got converted to single beam. From this column center to this center it is single beam. Okay, this is about join and divide beams. Okay, so now I will create slabs. So to create slab, first you should know the thickness. So here thickness of the slab is 150 mm. So in my problem statement, thickness of the slab it is 150 mm. So first you need to create a property to create a slab property. So you just go to define section properties. For beams and columns, it is frame sections. To draw or to define slab section, you click on this option, slab sections. Okay, there will be a default slab property. You go to add new property. So slab thickness of the slab is 150 mm. Thickness of the slab is 150 mm. Okay, so next, slab material, which means grade of concrete, it is M25. So modeling type, always keep shell thin in case of modeling type for slabs. So it should be shell thin only. Next, type slab thickness. Thickness of the slab is 150 mm. Thickness of the slab is 150 mm. You just click on OK. See here, new slab property has come up. So slab 150 mm. So you click on OK. Okay, so define section property, slab section. You go to modify. In modeling type, majorly you have two type. You need to concentrate on these two. One is shell thin. Another one is membrane. So if you see here, shell thin and membrane. So these two are very important. What will happen if I select shell thin? So if you select shell thin in modeling type, stiffness is accounted. So stiffness is accounted. Real behavior of structural slab. So it is the shell thin is the real behavior of structural slab. Which means moment and shear is taken by slab. So here moment and shear is taken by slab. What if I select a membrane option? Slab will not have stiffness in the model. So you please remember, slab will not have stiffness in the model. stiffness in the model. It will be only present there to transfer load as per yield line theory. So load will be transferred as per yield line theory. So moment and shear is not taken by slab. So here moment and shear is not taken by slab. So this is the difference between shell thin and membrane. So in case of shell thin, load transfer, it will be based on finite element method. In membrane, in case of membrane, so load transfer will be as per yield line theory. So here stiffness is accounted, which means moment and shear is taken by, some of the moment and shear is taken by slab also. Next, in case of membrane, so slab will not have stiffness, which means moment and shear is not taken by slab. You just keep it in mind. Okay, so this is the difference between membrane and shell thin. So in case of slab modeling type, so I select shell thin because I need a real behavior of a structural slab. So you click on OK. So once the slab property is ready, now you can draw the slabs, model the slabs, for which there are 3 ways to model your slab. So you can use 3 ways to model your slab. So I will explain one by one. So first you select this one, draw floor bar wall. You select this one. Okay. So your slab properties, this one, S 150 mm. S 150 mm. Okay. For drawing slabs, only have snap to joints in view. So you go to draw, snap options. You should have only joints in view. You remove this grid intersection. You go to apply. Okay. So you should snap to joints in view. So go to snap options. Here you check joints only in case of modeling slabs. You go to apply. Okay. So first, so I will take this part. So always make your slabs in a anti-clockwise direction by clicking on the nodes. See here. So you just click on this node in anti-clockwise direction. Again you click on this joint. You click on this joint, and this joint. See here. Your slab is modeled. Okay. So you please remember, while modeling the slab, always click on all joints which are going to be part of your slab. So I will show this one. So first I will close this. So I will select first option, select the property S 150 mm. You click on this joint, this joint, and last final. See here. So this is the slab. So I have taken story option as all stories. The slab is modeled on all the floors. The slab is modeled on all the floors. Even it is modeled on base also. At the base floor, you don't need any slab. Because of my story was all stories, the slab property is modeled on all the floors, including base also. Later you can delete it. So go to plan, ground, apply, OK. So this is your first option. Now I will select this second option. Now I will select this second option. So yes, 150. So for second option, you just place your mouse cursor on this joint and you just drag like this. See here. The first way is you can click on all joints, joint by joint. Okay. The second option is from left corner to left top corner to right bottom corner. You just click on this joint, column joint. You just drag your mouse and you just leave it here. See here. This is how the second option works. Next we shall see the third option. So third one will be this option, quick draw floors. You click on this. So your slab is 150. See, wherever there is a grid lines, here you have grid 2 and here you have grid 1 and here is your grid B. This is your grid C. So wherever there is a grid, you can just click it. Yes, see here how the slab is created. So there are three ways to create your slabs. Okay. How to see the property name of slab? You go to set display options. Set display options. In case of object assignment, shell. So in case of shell, so you please remember in ETABS slabs are represented as shell elements. So in case of ETABS, in the ETABS slabs are represented as shell elements. Okay, so beams and columns are represented as frame. Beams and columns are represented as frame elements. See here, whenever I say frame, which is related to columns and beams. Whenever I say shell, which is related to slab assignment. Okay. So you just click on sections, apply, okay. See here, the slab property is S150 mm. Similarly from beams also, you can now have the beam property names. You just switch off, apply, okay. How to bring it back? Same, set display options. You go to object assignments, you click on this sections, apply, OK, close. Okay, so this is modeling of slabs. So you go to plan, base level. You don't require slab here. Okay, you select one story, you select all the slabs, just mouse click, you select all the slabs. If you see the status bar, 6 shells, 24 edges selected. So slab 1, 2, 3, 4, 5, 6. 6 shells, how many edges? So each slab has 4 edges. So total 24 edges selected. So your story option should be one story. So on keyboard you click delete. So on base you have deleted all your slabs because it doesn't require. If you select all story here, your slabs are deleted on all the floors. Okay, so now you can see the 3D view. See here. Okay, so next I will explain this select, how to select your various structural elements. See here. So here my story option is one story. My problem is I have to select my horizontal beams at one time. At the same time I have to select my all horizontal beams. So my horizontal beams are 200 into 500 mm. I need to select all these beams in single click. How to select? So you go to select option. In select you go to properties. In properties you go to frame sections. Okay, so these are the frames which I have created. Okay, so your property name beam 200 into 500. You select beam 200 into 500 here and you just click on select. See here, all the beams with frame properties 200 into 500 mm are selected. If you see here, how many beams in this one story, which means it is ground floor. On ground floor, how many beams you have? 200 by 500. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9. You go to level up. Okay. Oh, so it will work on all the floors. Even though you have one story here, so all the beams are selected 200 by 500 mm in all floors. So you click deselect, close. Similarly, how to select all your vertical beams? So vertical beam property is beam 200 into 600. So if you want to select only these vertical beams, you go to select properties, frame sections. Your vertical beams are beam 200 into 600 mm. Select, close. Only vertical beams are selected. Okay, on all floors. So in 3D view, you just click mouse right button and only you just click on this option, show selected objects only. See here. So your selection property will be only on this view because you have selected only your vertical beams. So these are your vertical beams. So this how you can select your beams. So if you don't want, you just click on mouse right button and you just click this show all objects. See here. So how to select these slabs? How to select these slabs? You go to select properties, slab section. So for slab it is S150 mm select. See here, it is showing 30 shells selected, which means 30 slabs selected because you have 5 floors. So multiplied by, on each floor you have 1, 2, 3, 4, 5, 6 slabs. On each floor you have 6 slabs. So total numbers, so it will be 30 numbers. So it is showing 30 shells selected. Close. Again you use mouse right button and you select this one, show selected objects only. So here only you have selected objects in your view. See here, only your slabs. How to show all the elements? How to show all the elements? You click on show all objects. Okay. So replicate command, it will work for slabs also. See here. So here I have one slab at ground floor. How to replicate this slab on all stories? So first you select this slab. So this is your source slab, and you select all story here. Your story option should be all stories. You go to edit, you go to replicate, you just make it 0. So these are my old values. Okay. So in this replicate option, you select story. Now the slab is in ground floor. It should be modeled in first floor also, second floor also, third floor also. You use control button. You select first, second, third and roof. You just click apply. See here, the same slab is modeled on all the floors. So this is how replicate command will work. Okay. So in the last lecture, while modeling columns, we discussed general guidelines for columns and beams. So today we will discuss general guidelines for slab sizes. So general guidelines for slab sizes. Okay. So if you refer IS 456 2000, so you have L by D ratios for slabs of shorter span up to 3.5 meter and live load up to 3 kilonewton per meter square. If your slab is simply supported, okay, if you are using mild steel, then L by D ratio it is 35. For continuous slab, if you are using mild steel, then the ratio L by D ratio is 40. So for steel reinforcement, nobody will use mild steel. We are using HYST. So for HYST, L by D ratios are modified. So 35 multiplied by 0.5. So for HYST it is 28. For simply supported. For continuous slab, 40 into 0.8. So it will be 32. So these are for mild steel. These are HYST. So first is simply supported slab and second one is continuous slab. Okay. So just we will check the code. So where is IS 456? Yes. So IS 456. I forgot the page number. Yes, here on page number 39. So I'll remove this. On page number 39 you have the same guidelines. See here. First, for slabs spanning in two directions, the shorter span of the two spans should be used for calculating the span to effective depth ratios. So if you take slabs, you have two dimensions. One is shorter span and longer span. While calculating the effective depth, you need to refer shorter span. Okay. So next, second point, it is for two-way slabs of shorter span up to 3.5 meter with mild steel. With mild steel reinforcement, the span to overall depth. So these ratios are span to overall depth. Span to overall depth ratios are given below, may generally be assumed to satisfy vertical deflection limits for loading classes up to 3 kN per meter square. So for simply supported beam it is 35, for continuous beam it is 40. So these values are for mild steel. See here, for high strength deformed bars, which means HYST of grade Fe415, the values given above should be multiplied by 0.8. So which means 35 multiplied by 0.8, which is equal to 28. 40 multiplied by 0.8, which is equal to 32. So these ratios are for HYST. Okay. So similarly, for beams also you have span to depth ratios. Yesterday I forgot to mention. So let me check it for beams. See here. So you refer page number 37. The basic values of span to effective depth ratios for spans up to 10 meter. For cantilevers it is 7. For simply supported beam it is 20. For continuous beams it is 26. See here, these ratios are for spans up to 10 meter. If your span is more than 10 meter, what the code says is, for spans above 10 meter, the values in A, which means these values, may be multiplied by 10 divided by span in meters, except for cantilevers, in which case deflection calculation should be made. Okay. So these are the L by D ratios for beams. So generally if a shorter span is, if the shorter span of the slab is around 3 to 4 meter, then slab thickness would be overall thickness, so capital D, it would be 125 mm. If your shorter span of the slab is around 3 to 4 meter, you can have the depth of the slab as 125 mm. If it is 4 to 5 meter, if the shorter span 4 to 5 meter, you can have the depth of the slab as 150. So 5 to 6 meter, if the shorter span is around 5 to 6 meter, so overall depth of the slab will be 175 mm. If it is greater than 6 meter, then your slab thickness should be 200 mm. So these are based on thumb rules. These are not specified in any code. These are based on thumb rules. So thickness should be finalized based on the shorter span. Okay. So in today's class, I completed modeling of beams as well as slabs. See here. So this is your complete model. Columns, beams and slabs. So you remember in ETABS, always first model your columns. In ETABS, always first model columns. So then followed by beams and slabs. So this is very important. So while sizing, you remember this also. Use the same size throughout the project. So use the same size of beam, same size throughout the project. So try to avoid n number of sections. Avoid n number of, n means multiple number of, n number of sections. Okay, because it will help you to ease of execution and construction. If you use too many sizes, then it will be problem at the site execution, at the time of procurement of materials, at the time of shuttering also. Okay. So next thing is so in the last class we created this geometry. You created this geometry based on grid system. By creating the grid system, you modeled this building. If you want, you can import centerline diagram. If you want, you can even import the centerline diagram also. Just I will save this model. See here, I will demonstrate how to import a centerline diagram or grid lines. So this is the model or plan I was explaining. So already I have prepared the grids, same grids. These are column center line. So these are nothing but column center lines. So these grids are nothing but column center lines. So from here just I copied. So my columns are like this. Just I have made a copy of column center lines. Okay. So now I will show this how to import these grid lines to your ETABS. Okay. So your grid lines are under layer called grids. So these lines are under layer properties called grids. Okay, so first I will save this file. This is my CAD file. Just I'll copy this to a folder. I'll copy this to a folder. So just open it. Okay. You remove this, you delete this diagram. So you have only grid lines. You have only grid lines. Okay. So you just select all the grid lines, move to this corner. So use move command. You select this intersection and you move this to this origin. Okay, so save the file. You just go to file, save as. You save this file as DXF. So here files of type, you select DXF, save. Okay, you close this drawing. Yes. Okay, so now you have a DXF file. Okay, with grids. You just open ETABS, file, new model, use built-in settings, metric SI, Indian, IS 800, IS 456, 2000. Okay. You just enter your number of stories, 5, typical story height, which will be 3, bottom story height, it is 3 meter. Next, you select a blank here, click on OK. Next, you close this 3D view. So go to file, import. In import, you select this one, DXF file of architectural grids. You click on this. So this is the DXF file, which was say I saved it earlier. So you select this DXF file, open. So select layers of grids. So I told you in the beginning, the grids are named in layers called grids. So DXF file units, your DXF file units are in meter. So your DXF file, it is in meter. Global up direction in ETABS, X, Y, out of plane is Z. Okay, you click on OK. It will ask you to save your ETABS model. You give the name. So center line plan. You give any name. So save. See here. Your grid lines are imported directly. Later you can edit anything here. You go to edit stories and grid systems. Okay. In grid system, modify. You select spacing. So you can change the grid ID A, B, C, D. Here it is 1, 2, 3. You can increase or decrease the bubble size, or you can change the color of grids also. Okay, you can fix the bubble location also. I will select both. You see the change. So okay, refresh view. Okay, see here. So this is your grids. If you open your CAD file, So let me open the CAD file. See here. So your horizontal grids are spaced at 3, 4, 6 meter. If you open ETABS, so you go to options, graphic preference, increase the font size to 15. See here, your grids are spaced at the same distance, 3 meter, 4 meter, 6 meter. Your horizontal grids. See the vertical grids. Vertical grids are spaced at 7 and 5. So your vertical grids are same, 7 meter, 5 meter. So you same, next procedure will be same as earlier. You define the material property, section property, then draw the column, beam, slabs. Everything remains the same. I will show the columns, how to draw the or how to place the columns. You click on this option, you select the column property. So your column property is concrete column. You just drag like this. See here, your columns are modeled. Because my story option is one story, you will get columns in one story only. So this is how you can model. Either you can create grid system in ETABS, or you can import center line. You can import center line from AutoCAD as a DXF file. Don't use DWG files. When you import grid lines, the importing file format should be .dxf. Okay, so I completed the modeling process. So in last lecture and in today's lecture, I completed geometry in ETABS. So first I completed grid system. Second, story data. Next, third, defining materials. Next, fourth one, defining sections. Next, draw columns, beams, slabs. So I completed this part, geometry, how to create a geometry in ETABS. So next in the next part, I will take up loading, that is load calculations, and how to assign loads, the loads. I will take up this lecture in the next class or next video.